Welcome. Today we're talking about finding the composite function and domain. Up until this point, we've found the domain, but we haven't really touched on finding a composite as far as f composed of g, composed of working with x here. So our first step tends to be the same because we are finding f composed of g. We always want to begin with finding our domain of g of x. And to do that, and some of you guys have missed some of the previous classes, what we do is we take the denominator, and we're setting it equal to 0. So in this case, we'll go x minus 1 is equal to 0, add 1, x is equal to 1. Now, in the past, we found our domain of f and then set g of x equal to f. But now we want to do an alternative way in which we're finding a composite. Now, what is a composite? Basically, a composite is when we take our function of f and we put our g of x into that. So it kind of looks something like this. If I have 1, and in my f of x, there's an x there plus 2, and what I'm doing is I'm taking my g of x and I am substituting that in for my x. So in here I get the 4 over x minus 1. Now let's rewrite this in a way where we could go hold on, I gotta pause. Okay, so let's continue. Now, when we look at this 4x minus 1 plus 2, we notice that we have a denominator here we have a denominator in a denominator. So in order for us to come up with our composite, we're actually going to have to simplify that bottom piece of our denominator. Now, in order to do that, I'm going to want to put this fraction here. I'm going to want to convert this to have a similar denominator. Now, basically, I want to convert this fraction to be 2 over 1. I want it to convert it to where it is x minus 1. I want to convert it to where it would be a similar denominator there. Now, how do I do that? Well, I just simply multiply by 1 over 1, or x minus 1 over x minus 1. And what that does is it changes my fraction in the way it looks, but not the way it is. And 1 times x minus 1 is x minus 1. And then here, I'm actually going to distribute and get 2x minus 2. So I'm going to convert this into this here. So let's rewrite that and get 4x minus 1 plus 2x minus 2 over x minus 1. Now that I have a common denominator, what I could do is kind of compress that fraction and rewrite it as, let's go this way. We'll rewrite it as 4 plus 2x minus 2 over x minus 1. And what I've done is, I know that these denominators are the same, so I'm just kind of creating this numerator out of the top piece. And the one thing I have to recognize is that now I have some like terms I want to work with the 4 and the 2. And then I'll rewrite it as 2x plus 2 over x minus 1. Now this fraction bar here basically means division, right? It's a division bar, let's say. So if I rewrite this as 1 divided by 2x plus 2 over x minus 1. Anytime I divide by a fraction, all I'm doing is multiplying by its reciprocal or flipping. So I'll do 1 times x minus 1 over 2x plus 2. Now this right here, this is an important piece. This right here, this is my composite. That is my composite. That's a big piece right there. That's what we were searching for. We had our first piece of our domain, which we found here. This was a big piece. Here, we found our domain here. And now this other piece here, our composite, that's also a big piece. That's big stuff right there. We kind of lost it when we highlighted it, so we'll just keep it like that. Now, if we want to find the second part of our domain, we're going to take denominator from, I'm going to just abbreviate composite and set it equal to 0. So I'm going to take this piece here and say 2x plus 2 is equal to 0. Subtract 2, 2x is equal to negative 2, divide by 2, x is equal to negative 1. And so this here is my second part of my domain. So we have, or we'd write this as x is all numbers excluding 1 and negative 1. 1 and negative 1. Oh, I should have just put the little squiggly lines there. And so some of your important pieces here are, one is this domain of g of x. So we'll take note of that, domain of g of x. Then the second is our composite, f composed of g. Third is our second part of our domain by setting, our composite equal to 0. And then the other piece is coming up kind of with our notation of our domain for x. Now let's take this same example and just look at and show and demonstrate real quick. I forgot the shortcut. I'll do it in all red. The shortcut that Jeff was showing us the other class. So when I wrote my f composed of g, we wrote it as 1 for x minus 1 plus 2. What Jeff was showing us is that you could take or eliminate that x minus 1 variable by multiplying x minus 1 times x minus 1. And what you would have to do is, first understanding the distributive property, you would multiply 1 times x and get x, and 1 times negative 1 and get negative 1. That's our top piece. And then this x minus 1 is going to cancel out with this minus x minus 1, so you're left with 4. And then you want to distribute this 2 times x, 2x, 2 times 1, negative 2. Combining like terms, again, you end up with that x minus 1, 2x plus 2. This is our little shortcut here. And notice that is a match to the composite that we came up here. That's a direct match. That's the same exact thing. I would like for you guys to be able to show me both steps. We'll say the shortcut will be a bonus step given on any assessment. Okay, if you could show me how to do this, we'll count it as bonus. And I'll show you again when we look at the shortcut what g composed of f would look like using same function where f of x, let me slide this down a little bit, where f of x is 1 over x plus 2 and g of x is still 4 over x minus 1. Actually, let's rewind a second and this question here. Now, I'm going to take you through the whole thing again where we're looking at, okay, what is our first step? Our first step is finding the domain of our second letter in the composite. So in the last case, we found the domain using the denominator of g of x. Now we're going to find the domain by using the denominator of f of x and setting that equal to 0. So now I know my first piece, my domain here, first piece, put a star next to it, is x minus 2. Now in the last question, we took our f of x and put g of x into that. In this question, a little bit different. We'll take our 4, so we're using our g of x to start. Here is, and we have our variable x, and what we're going to be doing is putting the f of x in here and rewriting as x plus 2. So we put our f of x into where we had x here. And then common denominator, we're going to say 4, 1x plus 2 minus. Now in order to get it to x plus 2, I'll just multiply top and bottom by x plus 2. So that simply just ends up being x plus 2 over x plus 2. Let's rewrite consolidating our denominators here and get 4 over 1 minus x plus 2 over x plus 2. We'll combine some like terms, the 1 and the 2 here. I made a mistake here. Keep in mind, let's erase this, the distributive property. And here's where I made a mistake. This says with a little highlighter, we see that we have a subtraction sign here, which means that I needed to distribute that negative sign. So really I should have written this as 4, 1 minus x minus 2 over x plus 2. So that when I combine my like terms, the 1 and the negative 2, I should have gotten 4 over negative x minus 1 over x plus 2. Now just like the last one, we know this to be division. So we'll say 4 divided by negative x minus 1 over x plus 2, which is really 4 times flip x plus 2 negative x minus 1. Again, I have to use distributive properties. So this is really like 4 over 1. So I'm multiplying 4x plus 8 over negative x minus 1. And this is my composite. And remember, I take my denominator composite, negative x minus 1, set it equal to 0, add 1, negative x is equal to 1, x is equal to negative 1, to come up with my second piece of my domain. We'll say second domain here. And then if I want to notate, I would say, okay, x is all values excluding negative 1 and negative 2. And I've gotten those values from this and this. And if I want to look at the Jeffrey shortcut, in which I had 4, 1 over x plus 2 minus 1. Jeff tells us to multiply the top and bottom by x plus 2. This does not work all the time, but it does work very frequently. And then I distribute. We see it happening already. 4x plus 4 times 2, 8 over, this cancels out. So you're left with 1, and then distribute the negative 1. Negative 1 times x, negative 1 times negative 2, negative 2. And we finish with 4x plus 8 over negative x minus 1, which again is a match to our composite. So basically in all of this, it's just been find domain of second letter, because I know you guys like, give me the steps, make it easy for me. F of G or G of F, right? Or F composed of G, we're of this letter here. And then second step is find composite. By putting G of X into equation for F of X, and then the third, set composite denominator equal to 0.